Yeah. To summarize what we have discussed in the previous videos, we discussed the origin of the oculomotor nerve and its course inside the midbrain, and we agreed that the oculomotor nerve takes origin from the periaqueductal gray matter and the tegmentum part of the midbrain at the level of superior colliculus. It consists of two types of fibers, somatomotor fibers and visceromotor parasympathetic fibers. They are arranged together and they move as a single one fiber to the orbit to supply most of the extraocular and intraocular muscles. And we discussed the course of the oculomotor nerve inside the midbrain, and we agreed that the oculomotor nerve, after it takes origin from the periaqueductal gray matter, it moves anteriorly, it passes by the red nucleus, then it passes by the substantia nigra, then it approaches to the medial aspect of the gross cerebrus before it leaves the midbrain, then it leaves the midbrain through the oculomotor sulcus to enter into the interpeduncular fossa. Now we will go back to our original diagram, which is the lateral view of the brainstem. So, as we just mentioned, the oculomotor nerve takes origin from the midbrain at the level of superior colliculus, and this is the course of the oculomotor nerve inside the midbrain. Then the oculomotor nerve leaves the midbrain through the oculomotor sulcus to enter into the interpeduncular fossa. Here is a very important point that we need to understand very well. After the oculomotor nerve leaves the midbrain and enters into the interpeduncular fossa, it forms a special relation with the three different arteries. This relation can explain to us one of the well-known mechanisms leading to oculomotor nerve dysfunction. To understand the nature of this relation, it is very important to talk briefly about the origin of these arteries so we can understand the full picture. So we will discuss briefly about the subclavian arteries. We have two subclavian arteries. We have the right subclavian artery and we have the left subclavian artery, and this is the foramen magnum which separates the brainstem from the spinal cord, and this level of the spinal cord from C6 up to C1. So from the upper part of the subclavian artery, particularly on the posterior lateral aspect of the upper part of the subclavian artery, we have a branch. This branch is called the vertebral artery. So we have the right vertebral artery and we have the left vertebral artery. These vertebral arteries, they take origin from the upper part of the subclavian arteries. Then they move through the transverse foramina from C6 up to C1. One more time. The vertebral arteries, they take origin from the upper part of the subclavian arteries. Then they move through the transverse foramina from C6 up to C1 until they approach the foramen magnum. Once the vertebral arteries, the right and the left, they approach the foramen magnum, they terminate together to form one artery called the basilar artery. Then the basilar artery, it will enter inside the brain stem through the foramen magnum. After that, the basilar artery will continue its journey passing by the medulla oblongata, bones, midbrain until it approaches the cerebrum to give the terminal branches to supply the cerebrum. During its journey, the basilar artery gives a branch to supply the cerebellum. This branch goes to the superior aspect to supply cerebellum. So we call this artery the superior cerebellar artery. We have the right superior cerebellar artery and we have the left superior cerebellar artery. But because we are talking about the right oculomotor nerve, so this is the right superior cerebellar artery. Then the basilar artery continues to give the terminal branches to supply the cerebrum. These arteries go to the posterior aspect of cerebrum to supply cerebrum. So these arteries are called the posterior cerebral artery, and this is the right posterior cerebral artery. What I'm trying to emphasize on in this point is When the oculomotor nerve leaves the midbrain and enters into the interpeduncular fossa, it enters between the two arteries, as we can see. It enters below the posterior cerebral artery and above the superior cerebellar artery, and this is very important to us clinically. Why? Because when these arteries get dilated or aneurysm formation, they can press on the oculomotor nerve, causing oculomotor nerve dysfunction. This is one. The second point is, here we have the cavernous sinus. As we know, the cranial cavity is divided into three areas. We have the anterior cranial fossa, we have the middle cranial fossa, and we have the posterior cranial fossa. The brainstem is located in the posterior cranial fossa. In the middle cranial fossa, we have the cavernous sinus. We have actually two cavernous sinuses. They are located on both sides of the cilia tersica and the pituitary gland. The pituitary gland is located on the cilia tersica in the middle cranial fossa. In both sides of the cilia tersica and the pituitary gland, we have two cavernous sinuses. So this is the right cavernous sinus. Inside the cavity of the cavernous sinus, we have an artery. There is an artery which emerges from the cavity of the cavernous sinus. This artery is called the internal carotid artery. The internal carotid artery gives us two branches. It gives us the anterior cerebral artery, the ACA, and the middle cerebral artery, the MCA. Actually, there is a connection between the middle cerebral artery and the posterior cerebral artery. This connection is called the posterior communicating artery. When the oculomotor nerve leaves the midbrain and enters into the interpeduncular fossa, it enters below the posterior cerebral artery and above the superior cerebellar artery, and it moves parallel to the posterior communicating artery. That's why the posterior communicating artery aneurysm is one of the well-known mechanism leading to oculomotor nerve dysfunction. So these are the three arteries which can affect the function of the oculomotor nerve if they have like aneurysm formation or any abnormality.